All right, guys, so we're doing lesson 2-3 right now, study guide and intervention. So solving multi-step equations. We've gone over how to write an equation. We've gone over one-step equations when we just have to do one operation to get the variable by itself. Now we're gonna solve equations with more than one step to get the variable by itself. So one method that they give you, and it's just another way of thinking of how to solve. I don't particularly care for it, and for each of these steps that I do, I'll show you how I solve it. But it just wants you to kind of work backwards and undo what's being done. So I'll show you what I mean. Work backwards, I'm not gonna read through that. Example, a number is divided by 2, and then 8 is subtracted from that quotient, the answer you get after you divide by 2. The result is 16, what is the number? So, I'll zoom in a little bit. My method for solving that would just be to translate it, right? So my method would be a number. When I don't know what a number is, I call it x. So a number is divided by 2, and then 8 is subtracted from the quotient. Well, this is the quotient, so I subtract 8 from it. And then it says the result is 16. So to me, it's easier to write this out and now solve for x, right? And we'll go over in a second how to solve a multi-step equation. What they want you to think about is undoing everything they just said. So we start off with a number. We're trying to figure out what this number is. We don't know. So if it's divided by 2 and then subtracted 8 and you get 16, we're going to start with 16, and instead of subtracting 8, we're going to add 8. So we're doing the opposite of what they said. We start at the end. The end was 16. The last thing they did before the end was subtract 8, so we're going to add 8. And then before that, the answer was divided by 2, so we're going to multiply by 2. Right? And whatever that is, that's going to give us our number. So they're talking about working backwards. For me, and you might be different. I hope that this way works great for you. That's awesome. In my brain, I'm an overthinker, so I start overthinking this. And I'm like, but wait, why, that doesn't make sense. Why would I add? And am I doing that? It's too hard. I'd rather just translate it and solve it. But this is what they're talking about. So either way we solve this for x, we're going to get the same answer, right? So here, if I'm trying to get x alone, and this is what we're going to go over on the other side of the page, I need to get rid of the operation furthest away from x. So right now on this side of the equal sign where x is, I'm dividing by 2 and I'm subtracting 8, right? Well, this division, multiplication and division, directly touches my x. X divided by 2, they're written right there together. But minus 8, this 8 is further away, right? It's not right on top of x like 2 is right here up against x. 8 is not. So I always, when I'm undoing stuff, when I'm getting rid of numbers around x, I want to start furthest away from x and work my way closer. So I need to get rid of this minus 8 first. So I'm going to add 8 on both sides of my equal sign. So 16 plus 8 is 24. So then I'll have x over 2 equals 24. And then to get rid of divided by 2, I know I have to do the opposite and multiply by 2, right? Multiply this side by 2. And so I have to multiply this side by 2. These 2's cancel. 24 times 2 is 48. That's the correct answer, right? If you do the opposite or work backwards like they're saying to do, right? This is a little easier. Here is our variable, so now we can just simplify all the numbers on one side. 16 plus 8 is 24. And then I multiply that by 2. Oops, I meant x, not 8. 2 times 24 is 48. So we would still get the same thing. We would rewrite that as x equals 48. But we just solved it 2 different ways. So that's what this is talking about here. Another example, a word problem that I want to go over with you because you might see something like this on your homework or a quiz coming up. Just don't get frustrated with yourself when you're trying to figure out a word problem, because sometimes, like, we all trip up on it. We're like, am I thinking of it at the right angle? Like, I don't know where they're coming from, right? Just take it slow. So here, a bacteria culture doubles each half hour. So every 30 minutes, it doubles, right? It would start off as 2, then it would double to 4, then it would double to 8, then it would double to 16, then double to 32, right? It just keeps doubling. After 3 hours, there are 6,400 bacteria. After it's doubled 2 times an hour for 3 hours. How many bacteria were there to begin with? So again, me with how my brain works, I would start off with x, and then I know I multiply x times 2 every 30 minutes, okay? So I'm gonna multiply x times 2, that's the first 30 minutes. Then I'm gonna multiply it by 2 again because it's doubling. That's the first hour. Then I'm gonna multiply it by 2. Then I'm gonna multiply it again by 2, that's the second hour. And then I'm gonna do it one more time, right? Multiply it by 2, and multiply it by 2. That's 3 hours. So I've started with x, and I've multiplied it by 2 times 2 times 2 times 2 times 2 times 2, 6 times. And I know the answer is going to be 6,400. So basically, to figure out x, I need to undo all that multiplying. And instead of multiplying times 2, 6 different times, I'm going to divide by 2, 6 different times, right? And what they've set up here is, instead of dividing by 2, they just multiplied by 1/2. Instead of doubling this every half hour, they're working backwards and they're halving it every half hour, cutting it in half. They start off with the end product and they take half of it the first hour, half of it the second, half of it the third, half of the fourth, half of the fifth, half of it the sixth, and that will give them your final answer, right? So either way you set it up, however your brain works, like, awesome. That's good for you. That's how it works, right? So I'm gonna work on dividing by 2 this way. So to get rid of this first 2, I have to divide this by 2, right? And so that becomes 3,200. Then I have to divide by 2 again, and this is going to become 1,600. Then I gotta divide by 2 again, this becomes 800. Then I divide by 2 again, this becomes 400. Then I divide by 2 again, this becomes 200. And I have to divide by 2 one more time, and this 200 divided by 2 is 100. So the number of bacteria that we started with should be 100, right? If you did it their way and you started with 6,400 and you multiplied it by half, times half, times half, times half, times half. How do we know how many halves to do? Because it said every half hour for 3 hours. So here's the first half hour. Here's the first hour. Here, oops, I just circled the wrong 2, might be. Well, anyways, first half hour, second half hour, third half hour, fourth half hour, fifth half hour. There's 6 total. 1, 2, 3, 4, 5, 6, right? We're having it 6 times. So if we multiply 1/2 times 1/2 times 1/2 times 1, if we do that over and over and over, we get 1/64. And then if we multiply this by 1/64, you again get 100. To me, that way is super confusing. Even though my way looked funny and it was a lot longer, it made more sense in my head. I just undid everything. It's however it works for you. We will be looking at more word problems like this. I know that was super confusing, but I'm just telling you, you guys are gonna have to be able to figure those out, okay? All right, do we have any practice? No, we don't. Yeah, we do here. A number is divided by 3, and then 4 is added to the quotient. The result is 8. Find the number. Let me back up so you can see that. We're right here, number 1. A number is divided by 3. So for my way, I would do x divided by 3. Then 4 is added. So 4 plus 4. And the result is 8. So equals 8. Okay, so that's one way you can set it up. That's supposed to be an equal sign. The way they're telling us to set it up is to undo everything. So the result is 8. So we start with 8. The last thing they did to the result is add 4. So we're going to subtract 4. We're going to undo everything backwards. Before they added 4 and we subtracted 4, they divided by 3, so we're going to multiply by 3. And that is going to lead us to our original number. So either one we solve should give us the same answer. Here, if I subtract 4, I get x divided by 3 equals 4. Then I multiply both sides times 3, and x would equal 12. Over here, if I just simplify all this, 8 minus 4 is 4. 3 times 4 is 12, so x is going to equal 12. That's our original number. Number 2, a number is multiplied by 5. X, I don't know why I did it so little, times 5. Then 3 is subtracted, and the result is 12. So here's kind of the equation. The way they want us to do it is to undo everything. So we start off with the result, so we start off with 12. The last thing we did from 12 was subtract 3. So now we're going to add 3. And then we had multiplied by 5, so we're going to have to divide by 5. And that's going to lead us to our original answer. Okay, so if we start with this one, 12 plus 3 is 15. 15 divided by 5 is 3, so x should equal 3. If I did it this way and added 3 to both sides, I get 5x equals 15. And then I have to divide both sides by 5, so again, x equals 3. Gives me the same answer. Number 3, 8 is subtracted from a number. So I start off with my number and I subtract 8. And then the difference, whatever I get when I do this, is multiplied by 2 times 2. The result is 24. So all that equals 24. So I can set it up that way, or I can just go backwards from what they said. The result is 24, so we start off with 24. I had multiplied by 2, so now I want to divide by 2. I had subtracted 8, so I want to add 8. And that's going to lead me to my original number. Okay, 24 divided by 2 is 12. 12 plus 8 is 20. So my original number should be 20. If I started over here, 2 times x minus 2 times 8, 2x minus 16. If I add 16 over here, I get 40. And then I have to divide by 2. 40 divided by 2 is 20. I get the same thing. I'm not writing out all the steps, but I get the same thing. All right, 4. 3 times a number plus 3 is 24. Find the number. Is 24, so we're going to start with our 24. And we had added 3 to that, so I want to subtract 3. I want to go backwards. And I had multiplied times 3, so I'm going to divide by 3. And that's going to equal my number. So 24 minus 3 is 21. 21 divided by 3 is 7, so x is going to equal 7. A car rental. Angela rented a car for $29.99 a day, plus a one-time insurance cost of $5. Her bill was $124.96. For how many days did she rent the car? So for me, in my brain, I see this as a problem, or a math problem, right? Not like an issue, but a problem. Angela rented a car for $29.99 a day. So 29.99 times however many days she rented it. I don't know that. Plus a one-time insurance cost of $5. Cheap. Her total bill was $124.96. So this is my equation, right? And I'm solving for the number of days. How they would have done it, I believe, is start off with $124.96. Subtracted, instead of adding the $5, they would have gotten rid of that first $5. And then they had multiplied each day times $29.99, so we have to divide each day by $29.99, and that'll give us the number of days. So either way, whichever way you do it, once you solve for D, you can use your calculator, you should get D equals 4. And let me know if you need help with that. 124.96 minus 5 is 119.96. 119.96 divided by 29.99 in your calculator, right? 124.96 minus 5 divided by 29.99 equals 4. 4 days total. All right, and then 6, money. Mike withdrew an amount of money from his bank. We don't know what amount he withdrew. That's what we're going to solve for. He spent 1/4 for gasoline and had $90 left. How much did he withdraw? So I would write it as he took out X amount of dollars. He spent 1/4 of it. So times 1/4. And what he had left was $90, right? How they might have you set it up is working backwards. You start off with a 90. The last thing they had done was spend 1/4 of it or divide it by 4. So I'm going to multiply it by 4. And then that was it. So that's what we're looking for, X. Okay, so here to get rid of 1/4, I'm going to multiply this whole side of the equation by 4. So I got to multiply this side by 4, and 90 times 4 is 360. Times 4 times 4. These cancel. X equals 360. Over here, I just cut right to that, right? 90 times 4 is 360. Either way I solve it, I get the same answer. It doesn't matter which way you prefer. You can work backwards, or you can just write out the original equation and solve for x. Okay, so that kind of should have been the second page, because the first page is what we really needed to get to. How do I solve a multi-step equation? Well, I just explained that we want to start furthest away from x and work our way in, right? So I'm going to say that. Start furthest away from variable first. Got to get rid of all the stuff furthest away from x. And I want to kind of work backwards, use from the order of operations. So instead of starting with the, when you simplify something, instead of starting by simplifying with the harder stuff and then saving, adding and subtracting till the end, when you're solving for x, when you're undoing stuff, you want to get rid of those easy operations first and leave the more difficult stuff till the end. So we're going backwards with PEMDAS. First, we're going to add or subtract, then we're going to multiply or divide, then we're going to worry about taking the square root of anything or whatever radical, and then we're going to simplify parentheses. It's kind of how we're going to do it. So they give you an example, but we're just going to jump right in here to it because we've already done some. And I'm going to go down just this column over here. All right, so I have 5x plus 2 equals 27. To get x alone, it's going to take more than one step for me to do that, right? So I have a 5 touching x, so it's the closest one. And then I have this plus 2. And then all the way on the other side of the equal sign, I have a 27. So I'm definitely not touching that. I want to get x alone. So which one do I get rid of first, the 5 or the 2? Well, remember, backwards PEMDAS, I want to add or subtract first. Also, in my little world, I always get rid of what's furthest away from x first. So this 2 is separated by a plus sign. The 5 isn't separated by anything. So I want to get rid of this 2. To get rid of plus 2, I need to subtract 2. And whatever I do on one side of my equal sign, I do to the other. So I'm left with 5x equals 25. So now the only thing left to do, I'll write it up here, 5x equals 25, is to get rid of this times 5. To get rid of x times 5, I have to divide by 5. And whatever I do on the left side of my equation, I have to do to the right. So the 5's cancel, and I'm left with x equals 5. Okay, number 4. Here we have 14 times n minus 8 equals 34. Out of the 14 and the 8 that are next to n, I want to get n alone. I'm going to get rid of this 8 first. I'm going to add or subtract before I multiply or divide. So to get rid of minus 8, I'm going to add 8 on both sides of my equation to keep both sides equal. 14n equals 42. And then I'm going to divide, because right now it's n times 14. So I'm going to divide both sides of my equal sign by 14. 14n divided by 14 equals 42 divided by 14. And 42 divided by 14 is actually 3. So n equals 3. Okay, next I have 16 equals d minus 12 divided by 14. Okay, so this is a little tricky because the whole opposite PEMDAS thing doesn't work here, right? So it's true that normally we would get rid of this minus 12 first and then worry about dividing or multiplying. But in this case, I can't touch the top of my fraction until I get rid of the bottom, right? This is like the ground. You can't touch the top stuff here. It's standing on the ground. You got to get rid of this stuff up underneath it first. Then you can have a field day with it, right? So how do I get rid of divided by 14? I'm going to multiply by 14. I'm going to do it on a separate sheet of paper so I got room. Oops, sorry. Okay. 16 equals d minus 12 over 14. Okay, so to get rid of this 14, I'm going to multiply by 14, and they're going to cancel. And so I have to do the same thing over here, multiply by 14. And 14 times 16, I don't know off the top of my head, 224. And then I'm still left with d minus 12. I don't know why I wrote it so close there. 224 equals, I still have this up here, d minus 12. And then the last thing I need to do to get d by itself is to get rid of minus 12. So I'm going to add 12. And since I added 12 over here, I have to add 12 over here. These guys get canceled. 224 plus 12 is 236 equals d. Or d equals 236. Final answer. Okay, we're going to do the same kind of thing right here. 4b plus 8 divided by negative 2 equals 10. So before I can touch the top part of the fraction there, I have to get rid of the denominator. So 4b plus 8 all over negative 2 equals 10. Okay, so this is divided by negative 2. To get rid of divided by negative 2, I need to multiply by negative 2. And whatever I do on one side of my equal sign, I got to do to the other. So these negative 2's cancel, and I'm left with, 4b plus 8 equals 10 times negative 2 is negative 20. I'm trying to get b by itself, so I need to get rid of plus 8. Remember, I've got a 4 and an 8. The 4 is touching b, so I don't want to mess with that yet. I want to get rid of this easy stuff first. So minus 8, and I got to do the same thing over here. These cancel out. So I'm left with 4b, that was a weird b, equals negative 20 minus 8 is negative 28. I'm 20 feet down in the ground and I go down 8 more feet, I'm at negative 28. And lastly, to get b alone, I need to get rid of the 4. Since it's being multiplied by 4, I'm going to divide by 4. So I have to do the same on this side of the equal sign. 4's go away, and b equals negative 7. Negative divided by a positive is a negative. B equals negative 7. The cool thing about having a video instead of live teaching is that you can pause the video and rewatch it. So if I'm going too fast, I'm going to keep going because you can rewind it and rewatch it. But do let me know if you have questions or you need a better explanation. So what did we say this was? D equals negative 7. Okay, wrapping it up. We're already over 20 minutes. Number 13, negative 4 equals all this stuff. So this requires a little simplifying here. Sorry, number 13. Negative 4 equals 7x minus negative 1 all over negative 8. Right? And they have parentheses around the negative 1, but you really don't need to, because once you see two signs touching with no numbers in between them, you know you can't leave that, right? It's too many signs. So if there are two signs touching, you change them to a plus sign if they're the same. Two minus signs change to a plus. Okay, so now I'm looking at 7x plus 1, all divided by 8 equals negative 4. To get rid of divided by negative 8, I'm going to multiply by negative 8. So I got to multiply the left side of my equation by negative 8. A negative times a negative equals a positive. These negatives cancel each other out, so I'm left with 7x plus 1. Now, here's x. I have to get rid of a 7 and a 1. The 7 is touching x, so I'm going to leave that alone right now. I'm going to get rid of this plus 1. So I'm going to subtract 1, subtract 1. 7x plus 1, negative 8 times negative 8, 32. Yeah, I don't know, I'm gonna get a fraction. These go away. 32 minus 1 is 31 equals 7x. Did I do that right? Yeah, positive 32 plus 1 minus 1. I don't know. I don't know why it's gonna be a fraction, but it is. So then we divide by 7. Divide by 7, these cancel, and x equals 31 over 7, which we are capable of simplifying, right? So I'm going to simplify 31 over 7 into 7 over 7 plus 7 over 7 plus 7 over 7 plus 7 over 7. That's 28, 29, 30, 31 plus 3 over 7. So I just split it up into whole numbers, right? Anything over 7 is a whole number. So I had 7 over 7, that didn't equal 31, so then I added another 7 over 7, that's only 14. So I added another one, that's 21 over 7. So we added another one, that's 28 over 7, and then I had to add 3 more to get 31 over 7. And for each of these, they're actually one whole. Plus 3/7. So 1 plus 1 plus 1 plus 1 is 4. So the answer is 4 3/7. Positive 4 3/7. Makes sense? And if y'all catch any mistakes that I make, because I'm human and I make about 1,000 videos a week, not really, I don't really make 1,000, but I feel like I'm making videos. Because seriously, I have 6 classes and each class gets, intensive math doesn't get videos yet, but every other class gets 2 or 3 or sometimes 4 videos. And that's 5 classes and I'm making those for a week. There's a lot of videos. All right, last little piece of this lesson, last little thing, is not a big deal. I don't really know why I didn't already teach you this, but it's talking about equations looking for consecutive integers. In my video, consecutive integers are just numbers that come one right after the other, like 1, 2, 3, 4. So if we think about 1, 2, 3, 4, how could we represent that with variables, right? So when we represent consecutive integers, we always use n for the first number, and then everything after that is just based off of n, right? So 2 is 1 more than 1. So the second number is n plus 1. The next number is n plus 2. The next number is n plus 3, and so on and so forth, right? So if I was going to start with 8, and I wanted to know what the next 5 consecutive integers are, right? If 8 is n, then for the next number I'd have 8 plus 1, and then 8 plus 2, then 8 plus 3, 8 plus 4, 8 plus 5, right? The next 5 integers. So it's just n, and then everything after that, you're adding 1, and then 2, and then 3, and then 4, and then 5, based off of that very first number. So then when I simplify, I get 8, 9, 10, 11, 12, 13, right? Easy enough. So consecutive integers are just numbers that go in order, increasing, or you could have decreasing too. It could go down 1, but numbers in order, one right after the other, no missing numbers in between. Consecutive odd or even integers would be like 2, 4, 6, 8, or you could have 1, 3, 5, 7, and so on, right? Either one of those. So same thing, the first number is going to start with n, and then the next number isn't the very next consecutive number, right? It's actually 2 more than whatever the first number was. So instead of adding 1 and then 2, we're going to add by 2's. N plus 4, n plus 6, and then so on and so forth. And actually the odds, even though they're odd numbers, it follows the same rule, right? So we just keep adding by 2's. So if I was going to start with, let's say, the number 9, so if the first number is odd, then I'm finding odd integers. If the first number is even, then I'm finding consecutive even integers. So let's say I start with 9. And I want to find the next consecutive odd integer. So I'd do 9 plus 2, 9 plus 4, 9 plus 6, 9 plus 8. And if I simplify that, I get 11, 9 and 4 is 13, 9 and 6 is 15, 9 and 8 is 17, right? 9, 11, 13, 15, 17. We're missing 9, 10, 11, 12, 13, 14, 15, 16. We're missing the even numbers. Okay, if I wanted to find an even number, consecutive even numbers, just start with an even number and then use the exact same thing. We're adding by 2's. So if they're consecutive, we add by 1's. If they're odd or even, we add by 2's. So let's say we started out with 12. Then I would have 12 plus 2, 12 plus 4, 12 plus 6, 12 plus 8. Okay, and then I simplify and I get 12, 14, 16, 18, 20, and so on. So hopefully that makes sense. So these last couple problems down here, find 3 consecutive integers whose sum is 96. So consecutive means n plus 1, n plus 2, n plus 3. And it doesn't matter what the first one is, just any 3 consecutive integers. The first one's going to be n, the second one's going to be n plus 1, the third one's going to be n plus 2. Find 3 consecutive integers whose sum is 96. So I have this integer, and this integer, and I added them together, and it's going to equal 96, right? And then to figure out what the very first number is, I just add them all together, solve for n, right? So I have 1, 2, 3n plus 1 plus 2 is 3. That equals 96. I need to solve for n, so I'm going to subtract 3 from both sides of my equation. 3n, these go away, 3n equals 93, and then divide by 3, n equals 31. So if n is my first number and they're consecutive, it's got to be 31, 32, 33. And you can double check that by just adding them together. 31 and 32 is 63. 63 and 33 is 96. So that works. Okay, 17, find two consecutive odd integers. So this is when I'm adding n plus 2, n plus 4, right? When it's even or odd, there's numbers skipped in between, so I add every 2. If it's just consecutive, then I just add one number. So 2 consecutive odd. So I'm going to have n, whose sum, so I'm going to add them, plus, the next one is n plus 2. And that's going to add up to 176. So to figure out what those two numbers are, I first have to figure out what the first number is, so I solve for n. So I have 2n plus 2 equals 176. Subtract 2 from both sides of my equal sign. 2n equals 174. Divide both sides by 2. N equals 87. So two consecutive odd integers. One of them is 87. So what would be the next odd number after 87? 89. So we'll say 87, 89. Plus the first number is n, and the second number is n plus 2. So 87 plus 2 would be 89. And then lastly, find three consecutive integers whose sum is negative 93. Consecutive, and they equal negative 93. So that's n plus 1 plus n plus 2 equals negative 93. N plus n is 3n. 1 plus 2 is 3. Negative 93. I'm solving for n. I'm going to subtract 3 from both sides. Negative 96. Negative 96 divided by 3 is 32. Negative 32. So the first number is negative 32. Three consecutive integers whose sum is negative 93. If n is negative 32, then n plus 1 is negative 31, and n plus 2 equals negative 30. All right, negative 32, negative 31, negative 30. Hopefully that didn't confuse you guys too bad. We'll go over it more. I'll try and give you like a, not bell work, but I'll give you some little something to practice that the next video I put up. Okay, let me know if you have questions.